Brakes must be the most abused component on any vehicle. They must operate correctly under a wide variety of conditions. Disc brakes are the most common system used by the OEMs, and to professionally repair them, a technician needs to fully understand how they function. Disc brake units are comprised of a master cylinder, a disc or rotor, a hydraulic caliper fitted with brake pads, and the lines connecting the hydraulics. Together, they provide a very efficient and effective braking system. Disc brakes are very resistant to heat fade during hard or prolonged operation due to their excellent heat dissipation. They are also generally unaffected by water immersion because the rotation of the disc and the operation of the pads tends to remove the moisture very quickly. Another advantage of disc brakes over drum systems is that they automatically adjust as the pads wear. Passenger and light-duty commercial vehicles typically use rotors made from cast iron. These may be constructed as a single unit or manufactured in two parts, the hub and the friction surface. The friction surface is machined on both sides of the rotor to provide a mating face for the brake pads. We can classify disc rotors by their hub design. They can be either a fixed or floating rotor. A fixed rotor is designed as a single unit, which houses the wheel bearings and wheel studs, and acts as an anchor point for the wheel rim. A floating rotor is cast with a hub flange and precision-drilled wheel stud holes that allow the rotor to be bolted to a separate wheel hub. Both fixed and floating rotors may be subcategorized as a solid or vented type. Vented rotors are normally seen on the front axle, but can be used on all corners of the vehicle and are manufactured with cooling fins cast between the machined braking surfaces. Venting helps increase the cooling efficiency of the rotor by providing a greater surface area to disperse the heat created by friction. The rotation of the disc increases air circulation through the cooling slots between the braking surfaces. When in operation, air is drawn from the inner edge of the rotor assembly and is passed through the vents, where it takes on the heat energy from the rotor. The air is pushed to the outside of the rotor, where it is able to mix with and then dissipate the heat energy to the airstream created by the forward momentum of the vehicle. Although the ventilated rotors are larger and heavier than solid rotors, increasing the unsprung mass, their disadvantages are more than offset by their cooling ability. Brake rotor manufacturers also drill holes to aid surface water dispersal, removal of dirt, dust and mud, reduce noise, and for overall weight reduction. They may also have slots or grooves machined into the disc friction surface. These are designed to allow any heat-generated gases and brake dust to escape. The downside of this design is the overall decrease in the surface area of the rotor, which reduces its thermal capacity. Brake rotor manufacturers design high-end and racing components with weight reduction in mind. To address this, composite rotors are used. These are made from various materials such as reinforced carbon and exotic ceramics. Composite brakes can withstand high temperatures that would make conventional rotors soften and then fail. Additionally, composites weigh about half that of conventional brakes. With lower unsprung mass, ride quality and handling is improved, while fuel usage is reduced. Brake calipers convert hydraulic force into mechanical force and are available in a variety of designs. Conventional brake calipers can be constructed from cast iron or aluminum and may house up to 4 pistons. In some performance applications, 6 and 8 piston brake calipers are common. Regardless of the number of pistons housed in the brake caliper, they are classified as a fixed or floating type. A fixed brake caliper is where the housing is bolted to the steering knuckle or rear axle in a stationary position. The housing does not move when the brakes are applied. Instead, hydraulic fluid under pressure is pushed into the caliper housing, acting on the pistons. They then move through their bore, sliding over a caliper seal. The seal is a square section type that twists or deforms in relation to piston movement. All pistons in the caliper are pressed inward, forcing the brake pad against the rotor. This action creates the friction required to slow or stop the vehicle. When the brake pedal is released, the drop in hydraulic pressure lets the pistons retract slightly, allowing the pads to move away from the rotor. On release, the seal returns to its original shape, aiding the pistons in their return to a neutral position. The seal is, in effect, acting like a return spring. The construction of a floating caliper is different than that of a fixed. A floating caliper has 2 components: an anchor plate and a hydraulic caliper. The anchor plate is bolted to the steering knuckle or rear axle. Teflon-coated guide pins locate the caliper housing in its correct position, but allow lateral movement or float during brake operations. Usually, floating calipers utilize 1 or 2 pistons in the inboard side of the caliper housing. When the brakes are applied, the hydraulic pressure from the master cylinder presses the piston against the inner pad and the inner pad against the rotor. As the pad contacts the rotor, hydraulic pressure acts against the back of the caliper cylinder as well as against the piston, and this causes the housing to slide on its guide pins. This movement is transferred through the caliper to the outer pad, which is also forced against the rotor. Both pads are applied with equal force. Brake pads come in all shapes and sizes, but they are constructed in a similar way. They use a steel backing plate with a friction material bonded to the surface. The pads are positioned in the housing by guide lugs that fit into slots in the caliper. Some pads are held in place with pins that go through holes in the pads. Anti-rattle clips or springs are fitted to the caliper or pad to prevent the pad from rattling in the slots when the brakes are released. Wear indicators may also be used and alert the driver when the pad has worn down to its minimum thickness and needs replacing. An audible indicator is a thin spring steel tab riveted or pressed onto the pad's backing plate and is shaped to contact the rotor when the lining wears down to its minimum thickness. As the steel tab comes into contact with the moving rotor, it creates a high-pitched squeal. Many vehicles are fitted with an electronic device that illuminates a warning light on the instrument panel when the pads are worn down to their minimum limit. Another common brake pad wear indicator that can be used by the vehicle's driver or the technician is the brake fluid level sensor. As brake pads wear, the caliper piston extends from its housing, closing the gap between the pad and rotor. Brake fluid from the master cylinder fills the void created by the piston, resulting in a reduction of the fluid level in the reservoir. When the fluid drops to its minimum level, the sensor attached to the reservoir signals a warning to the instrument cluster, either directly or through a control module, to turn the brake fluid level indicator on. Unfortunately, topping up the brake fluid between or during routine service events negates the effectiveness of this type of brake pad warning system. Modern passenger vehicles that use a four-wheel disc brake system also require a parking brake system that will hold the vehicle stationary when applied. Generally, there are two different systems used for park brakes: the disc drum park brake or the caliper actuated park brake. The disc drum system utilizes a brake shoe assembly inside the rear wheel disc hub, with a normal disc brake caliper on the outside. When the park brake lever is applied, a cable or linkage connected to the park brake shoes at the rear axle moves the shoes against the inside of the rotor, applying the park brake and preventing movement of the vehicle. A similar action takes place with a caliper integrated park brake. When applied, a cable actuates either a screw type or ball and ramp type mechanism. The screw and nut type operates when a lever on the rear of the caliper housing rotates the actuator screw. Because the nut is splined to the inside of the cone, it cannot rotate, so it forces the cone outward against the inside of the piston. This forces the piston out and pushes the inner pad against the rotor. The force from the inner pad causes the caliper to slide and engage the outer pad, applying pressure to the disc rotor. A thorough understanding of the disc brake systems is absolutely critical when trying to diagnose or repair any problem.